rational function if f and g are polynomial functions and g of x not equal to 0 for all x belongs to R, then f by g defined as f by g of x equal to f of x by g of x. This is called a rational function. Next, 17th one, algebraic function. A function obtained by applying a finite number of algebraic operations on polynomial. It is called an algebraic function. Next, 18th one, exponential function. The function a power x where a not equal to 1 and which is greater than 0 and x is rational. This type of function a power x, it is an exponential function and its domain is R and its range is R plus. Take an example of exponential function. For a equal to 1, the graph looks like this. Another example, y equal to 2 power x. For x values 0, 1, 2, put x equal to 0, then 2 power 0 is 1, and if you put x equal to 1, y is 2 and it is 4. The graph is, so for a greater than 1, here it is a equal to 2 which is greater than 1. So for a greater than 1, the graph is looks like this. The same way for 0 less than a less than 1. For a equal to 1, the graph is like this. For a is greater than 1, the graph is an increasing graph, and if a is less than 1, the graph will be like this. So if x increases, then there is an increase in y. Next one is a logarithmic function. If a greater than 0 and which is not equal to 1, given y is also greater than 0, then there is an unique x belongs to R such that a power x equal to y. So this type of function is a logarithmic function. The function is defined on R plus. Okay, suppose a power x equal to y, you can also write x equal to log y base a. Base a. If the base is e, then that logarithmic function is called a natural logarithmic function and it is denoted the natural logarithmic function. So in this natural logarithmic function, e power x equal to y, then you can write it as x equal to log y base e. And its domain is 0, infinity and range is R. Next one is greatest integer function. The function f maps R to R and defined by f of x equal to step x. This is called step x for all x belongs to R. It is called a greatest integer function. Okay, and its domain is R and the range is z. And the graph of greatest integer function will be like this. Okay, the greatest integer less than or equal to x. Like suppose take an example 1.5. Okay, take an integer because the range is always an integer. So for 1.5, 1. For minus 2.5 it is minus 3 because minus 3 is less than minus 2.5. Next one is modulus function. The function f maps R2 are defined by f of x equal to mod x for each x belongs to R. So f of x, it is positive x for x greater than or equal to 0, and it is minus x if x less than 0. The graph of y equal to mod x is, because all are positive values. This is the graph for y equal to mod x. Okay, next one is signum function or signum function. A function f from R to R defined by signum of x equal to f of x, which is equal to mod x by x. It can be defined as, if it is positive x is greater than 0, the answer is 1. For x equal to 0, signum function is 0. For x less than 0, it is minus 1. So its domain is R and its range is always minus 1, 0 and 1. And its graph will be for y equal to 1, and this is for y equal to minus 1.